Okay, so my name is Enzo, and me and my partners, Joanne and Lauren, have put together a presentation to show you our plans for a mission to Titan. Whether you are concerned with its atmosphere, surface liquids, or its prospects for life, there is plenty to learn about Titan. My group has decided to focus our efforts on studying its geology. First, let's start off with what we already know. Most of the details we have on Titan are owed to the analytics from the Cassini-Huygens mission. The Huygens lander detected that the topography of Titan's surface is relatively level. While there are areas of higher altitude, they remain pretty low and spread out. Before spacecrafts were sent to Titan, it was expected that it would be home to global oceans composed of methane, ethane, and other light hydrocarbons. Instead, what exists on the surface are hundreds of hydrocarbon lakes concentrated near the poles. In addition to these lakes, rivers of liquid methane span across the surface, yet show little signs of erosion. Concentrated around the equator are dunes thought to be made from hydrocarbon grains that have settled out of the atmosphere. Impact craters are an important part of telling the story of a world. However, on Titan, there have only been around 5 certain impact craters found. Here we have an image mapping some of the major hydrocarbon lakes on Titan. They are concentrated around the poles because there's a relative lack of sunlight that prevents them from evaporating. So, what are we trying to find out? Well, by studying the surface, we aim to answer a question about one of Titan's most intriguing and seemingly unrelated aspects, its atmosphere. This incredibly thick haze is home to an amount of methane gas that would be impossible to accumulate by the methane on the surface. It has been suggested then that certain geological processes are responsible. One likely process is volcanism. Cryovolcanism has long been thought to exist on Titan's surface, but no clear evidence has ever been found. So, our goal of discovering active volcanism would not only confirm this long suggested theory, but solve the puzzle of methane in the atmosphere. The concentration of dunes around Titan's equator is another problem in need of an answer. We hope to study the composition of these dunes and see what contributes to this concentration. Some beneficial byproducts of this will be information on Titan's wind and climate patterns. Understanding these will help unravel the processes of erosion. Titan's surface has very little signs of erosion. It is uncertain whether this is due to young rivers, slow erosion, or an overlying geological process that's erasing the large signs of erosion. So, getting a better understanding of how erosion works on Titan will be helpful in discovering the story of the surface of Titan.
Hello, so this is now Joanne. So I'm kind of going to talk about how we aim to accomplish these goals that Enzo mentioned in the first half. So our group aims to send a rover and land it at the Minerva site on Titan, which is also home to the largest crater on the moon. Within this crater, we believe that it may potentially be home to cryovolcanoes, which is a major question that we had asked in the first part. Minerva is also within close proximity to the dunes on Titan, which we also plan to examine and study to try to answer our questions about why they might be centered specifically around the equator. You can see in the map right here, Minerva is right here, and the dunes are all this purple area. So through the progression of our mission, we aim to move our rover down to Xanadu in this region right here, which is also home to the hummocky grounds, so everything yellow you see is like the hummocky region. Within these hummocky grounds, they also contain immense erosion, which may also give us a better idea of the geologic processes that occur on Titan and potentially which order they may occur in. On our rover, we want to install a chem, which essentially fires a laser and analyzes the elemental composition of vaporized materials from extremely small areas. So right here you can see the laser beam shooting into the rocks. That's kind of what it looks like right there too in this area. The chem will allow us to gain a clearer understanding of the composition of Titan's materials, and it'll also help us to answer the question of the geological landscape and its processes. Next up, we would also like to install a small robotic arm on our rover so that we can utilize other instruments that need to be close to the samples. And in this image right here, we kind of have an idea of what we want the arm to look like. So within this arm, it kind of needs to have other tools working alongside it. So some of them include the rock abrasion tool, which is essentially a powerful grinder able to create a hole about 2 inches in diameter and 0.2 inches deep into a rock on the Martian surface. So the significance of this would be that the interior of a rock may be very different from the exterior. So the difference is important to scientists as ourselves, as we may want to reveal how the rock was formed and the environmental conditions in which it may have been altered from what we see on the exterior. So what we mean by this is that a rock sitting on the surface of Titan may have become covered with dust and will weather over time. Or it might also change in chemical composition from contact with the atmosphere. The alpha particle X-ray spectrometer, also known as the APXS, determines the elemental chemistry of rocks and soils using alpha particles and X-rays. This will be useful in determining the elements that compose rocks and soils, providing information about the crustal formation and weathering processes. This is the Moss-Bauer spectrometer. It identifies iron-bearing minerals and may yield information about early environmental conditions on Titan. So this will help us answer the question of what geological processes occur on Titan and what they were like in its early years of formation. This is the microscopic imager, and it provides us with an extreme up-close view of rocks and soils. This provides context for the interpretation of data about minerals and elements. It complements the findings of other science instruments also included with the robot arm by producing close-up views of surface materials. Some of those materials are in their natural state, while others may be fresh surfaces exposed by the rock abrasion tool. Right here we can see what the microscopic imager looks like on the rover. This is the miniature thermal emission spectrometer, also known as the mini-TESS. It is usually placed in the rear of a rover, right here, as shown in the image, and it measures the different spectrums of infrared light or heat emitted from different minerals in rocks and soils. This will help us determine the mineralogy of rocks and soils from a distance by detecting their patterns of thermal radiation. The mini-TESS is specially tuned to look for minerals formed in the water. This will prove to be useful for when we are exploring the methane and ethane rivers that exist on Titan.
The mission to Titan is important because we need to conduct a geological survey of the surface of Titan, and this is essential because the presence of volcanoes would be an indicator that would further help us understand and really break down the composition of Titan's atmosphere. And by further understanding Titan's atmosphere, that would just open the door to so much more data and things that we could discover about Titan. So that is great. The image is a surface map of Titan, which I thought was super cool because you could see the density, like, it's just really detailed, and I thought it was really cool, so I just wanted to put it in there. So why are these discoveries from the mission important? So if we were to discover that life could be supported on Titan, that would be monumental, not just for history, but in general, but specifically for astronomy, because when you can study how life behaves on another celestial object, that just would give us so much more information and data about life here on Earth, and we've never had another like point of comparison. So being able to have that point of comparison on Titan would be very significant and monumental for astronomy. So I liked this little graphic because this astronaut is pondering, like, what would life on Titan be? So yeah, I just wanted to insert that too because it's good to be curious about different opportunities and possibilities, and curiosity is the root of learning. So next slide. So what are the benefits from this mission? So this mission is valuable because it has the potential to provide, like I said, concrete results via qualitative and quantitative data that we would acquire during the mission. And and being able to study the geological composition, which just opened the door to information about the atmosphere. And once again, I encourage you to invest in this mission because it is logistically set up and planned so that if we don't find life on Titan, so be it. But we're going to find data, we're going to find information, and it's going to be, a great mission. So, I just want to say thank you for listening. Here is another map of Titan's surface. It is so cool. Okay, thank you guys.